Algebra 2, how's it going? We're hanging in there. We're good with quadratics, hopefully. We've done 2 of the forms already. We talked intercept form. It was really easy to find the x-intercepts by setting those parentheses, those factors, we'll call them, equal to 0. Sometimes it was switching the sign. Most of the time it was switching the sign, but that's not really what's happening. Then we learned standard form, ax squared plus bx plus c. We had a couple little formulas, but a lot of the stuff still held true, like finding the AOS and then plugging that back in to get the vertex. So we're down to the last form that we're going to talk about. The last form of a quadratic for us is going to be vertex form. And hopefully it makes sense why we would call it vertex form. The good news is it's going to mimic a lot of the stuff we did with absolute values. So a lot of this is going to be familiar, hopefully. So without further ado, you have your follow-along sheet. Let's go ahead and fill it out together. And then when you're done, take that information and put it on your foldable. Okay, we have our notes. Start filling out. Oh, that one's not done yet. Oh, there we go. Start filling that out for yourself, okay? So you have your handy-dandy little notes always ready to go. So let's get after it. It's called a vertex form for a very specific reason, because it's really easy to find the vertex, right? The vertex is h comma k, just like it was for absolute values. Vertex form actually looks like this. It's y equals a, parentheses, x minus h squared plus k. So if you substituted the parentheses and squares, if you took those out and put absolute value symbols, those straight lines, they would be the same thing. And a lot of the stuff holds true. So it's really easy to find the vertex. You switch the sign on h, and you leave k alone. H, k, that's what's going to happen. Please don't forget to switch the sign on h. There's a sign flip. Don't forget it. Most of us did a good job of that and not forgetting that on absolute values, so don't forget it now. Let's find the vertex for each. Go ahead, take a minute, see if you can find the vertex for these 3 problems. Hit pause, come back, and see if your answer matches mine. Okay, you're back. Switch the sign on h, leave k alone. H and k. There's the vertex. On this one, it's invisible, but it's there. H and k. Switch the sign on h, leave k alone. There's our vertex. On that last one, doesn't look like it's in vertex form, but it is. It kind of is in standard form too, depending on what we want to fill in here. But to make this vertex form, that x, we need that h. What are we adding to x inside of here to leave it as x squared? Well, we can always add a 0. So here it is, this quadratic written in vertex form. So the vertex would be 0, 10. Switch the sign on h. Doesn't really matter because 0 doesn't really have a sign. It's not positive or negative, so just leave it as 0. And then k. H, k. Finding the y-intercept. Now, I don't want you to get confused here. The y-intercept is not this back number. That was standard form. It's the back number, the constant c. But this isn't c. This is k. This is a different variable. To find the y-intercept for all these, you have to plug in a 0 for x, just like we did on all these other ones. So I'll pick one. You do all of them. I'm going to check and make sure you did all of them as part of this follow-along notes. I will do one of them. Plugging in a 0 for x. Let's go to the first one. -3. I'm taking the x out, and I'm putting a 0 in its place. You can use a calculator. I can use Desmos. 0 minus 2, -2. Squared comes next. That would be 4 times -3, -12. -12 minus 11, -12 minus 11 is -23. Our y-intercept would be 0, -23. You could just write -23 too. I won't be picky. Go ahead and find the x-intercept or the y-intercepts for those other 2, please. Next, what about the AOS? How do we find the AOS? Well, just like before, the axis of symmetry cuts our parabola in half. Remember, here is our parabola. The axis of symmetry will always cut our parabola in half. So it always goes through the vertex. So if we already have the vertex, we already have the axis of symmetry. It's always h. The axis of symmetry is x equals h. Don't forget the x equals part. That shows me you know it's a line. The axis of symmetry is a line. So let's look at them. For this one, it would be x equals 2. For this one, it would be x equals 2. For this one, it would be x equals 0. X is always the same as h. And finding h is really easy because it's vertex form, h comma k. Okay? For all, if a is negative, that means our parabola opens down. And if it opens down, It has a maximum. It has a top to it. Okay? Then the opposite of that. If A is positive, then our parabola opens up and has a minimum value. Parabolas that open up have bottoms to them, has a bottom, not a top. Okay. Finally then, we want to be able to sketch graphs of these things. Sketch a graph, use the graph to predict different things. So there's 3 steps to this. Step 1 is to find the vertex / AOS. Because, right, if you found the vertex, you found the AOS. So we'll find and graph and plot, we'll say, the vertex and the AOS. Step 2 is to make a table with vertex in the middle. And then finally, we're going to use symmetry. The whole point of the axis of symmetry, I mean, it's something that's just there, but why do we need it? We can use it to help shrink our work down. Okay, let's sketch a graph for this one. It says to first find the vertex and the axis of symmetry, okay? The vertex would be at -3, -2, -2. That means the axis of symmetry would always be the h, would be x equals -3. Now let's make our table. So my little x, y, t chart a little. The trick is, because this a value is 1/2, I'm actually going to go by 2 when I go branch out. Normally, if it was just a 1, I could go up by 1 this way, down by 1 this way, but I would get some fractions if I did that. And we can handle fractions. We have calculators, and we know about fractions. But to make life easier, we want easy points. I'm going to go by 2, so I'm actually going to drop it by 2 this way. And I'm going to increase it by 2 this way. We don't actually have to find each of those values. We only have to find one. Because of symmetry, we automatically have the other. So let's plug in a -1. I'm going to plug in a -1. -1 plus 3 is 2. 2 squared is 4. Half times 4, half of 4 is 2. And 2 minus 2 is 0. We actually found, by plugging in a -1, it kicked out a 0. When my y value is 0, that's an x-intercept. We actually found the x-intercept for this thing. So we have our little table. Vertex, axis of symmetry, table with the vertex in the middle. Now we just sketch a little graph of this. Let's see, -1, 0. It's -1, 0. -5, 0. 1, 2, 3, 4, 5, 0. -3, -2. 1, 2, 3, 1, 2. There's my vertex. It opens up. Yeah, it does open up. It's a positive. We can axis of symmetry down the middle we use. Something that could be helpful too, if you're not sure how much it rises. Is it really narrow? Is it wide? This one should be wider, just like absolute values. But you can find the y-intercept. You can find another point. The more points you have, the more definite you can make your curve. But that's it. We just learned about vertex form. It's just like absolute value, only we're U-shaped, not V-shaped. We're quadratic. Okay. Fill out your yellow sheet now. Fill out your yellow foldable. We have intercept form, standard form, and then finally we're going to have vertex form. Go through and fill out what you just learned on this little paper and have it on your yellow note sheet and come armed with it in class, and we'll do our homework in class. All right, you guys. Peace.